here's a quick recap of how we got here. First of all, we built a weapon. Then we built a test harness to try it out and see if it would actually spin. Next, we built a prototype out of wood, make sure that everything would actually fit together. And we learned quite a few lessons from that. We need to make these wheel arches a bit wider to give us a bit more clearance. And our original idea of having two weapon motors didn't really fly, so we've gone back to one just like we had in the original prototype. We're going to be using this V-slot aluminium extrusion for most of the internal structure. The nice thing about that, it's got these rails here so we can bolt things onto it. So spent a lot of prep time building mounting brackets for basically everything that's going on inside. So for the batteries, removable links, LEDs, speed controllers, radio receivers, the whole works. So that way we don't need to drill holes in anything, we just slide these on, fit them wherever we like, change our minds if anything doesn't quite line up. So now, after all the prototyping and mounting bracket making, we can't put it off any longer, it's time to start marking out some metal, going on with cutting, drilling some holes, and putting a robot together. So the last couple of days we've taken a sheet of aluminium like this, painstakingly marked it out, and then cut it out with a jigsaw. So it's a case of, you have to measure 6 times, cut once. So we've transformed this into this base plate for our new featherweight robot. So after 3 days of marking, cutting and drilling, we have a completed base plate. The next step is to take our aluminium extrusion, cut these sections to length and fit everything together. So here we are, a lot more cutting later. We have our extrusions all cut to size. And so this will suddenly start looking like a robot when we put it all together. Now, some assembly later, got the outlines of a robot put together. That's the beauty of this V-slot extrusion. We make all the brackets for things and then everything just goes together really quickly. A day ago this was just a flat sheet of metal and now it looks like the outlines of a proper robot. Now we've got the basics of the robot together, the next thing to do is finish up the electrical system. So put some leads on these LEDs and put a proper removable link in place. Here we have our first real live weapon test. As you can see, we've got around to putting in a proper removable link. We have green LEDs that come on to show that everything's all working. And here we go, spinning up the weapon for the first time. As you can see though, it's not all good news, and the belt tensioner is happily unscrewing itself. The final build will have a slot to allow for an adjustable belt tensioner, but in the interest of time we tried with a shorter belt to make sure everything's bent up properly. With the weapon test complete, it's now time to move on to putting the armour onto the robot. So this is the full metal jacket that gives the robot its name. We've got some 5mm aluminium that's been cut, fettled and centre punched, all ready for drilling. Some drilling and deburring later, we now have all the pieces of the full metal jacket armour. So the next step, do a test fit, make sure everything goes together properly. Here we have a minimal chassis assembled. Now it's time to try and fit the armour. Here's the first test fit of the armour for full metal jacket. Overall, everything goes together reasonably well. We need to tap a thread into the end pieces so these can bolt on properly. Here's our final test assembly showing all the armour in place. 2 extra pieces here and here to protect the corners, ready to power up and see if it all works. Now it's powered up, you can see all the extra LEDs we put in. We also have a ghostly green glow If the spinning bar wasn't scary enough, then the green eyes at the front should put the fear into any other robot.